Professor and TA. We are Team 11 Penguin. We implemented the decision tree learning task on both task A and task B. For task B, we use the binary label dataset. We develop our program in Java using 83 algorithm for decision tree. For pruning strategy, we choose REP, reduce error pruning. In data pre-processing stage, we discrete the continuous value by finding the split point that makes the largest information gain. We write code to make our learning algorithm find the most appropriate split point automatically. In decision tree training stage, for ID3 algorithm, we choose maximizing information gain as our splitting rule. Maximizing information gain is a strategy to reduce data entropy by the most. The entropy expressed by the sum of proportion times logged proportion of different class. In testing stage, because our dataset is not rich and we don't have extra testing data, we choose 10 force cross-validation to calculate the accuracy of our decision tree. Now, let's move to the implementation detail and analysis of our learning result. We have 7 class files in total. The LHelper class is used to read raw data, discrete continuous value, and finally generate an array list to store all data. All values are string type. Get attribute list methods is used to read all attributes name and save them to a list. Read data methods is used to read all attributes name and is used to read raw data. In this function, we also try to find the split point with largest information gain. To build the tree, we design the tree node class. A node instance contains the attribute name that uniquely dominates the node. It also contains a list about how this attribute can be split, a list of its children nodes, the subset of raw data in which all elements satisfy the path from root to this node. The rest attributes list is the list of candidate attributes can be chosen to continue generate tree after this node. For convenience and efficiency, we also design the counter helper class. This class provides some dataset scan and query functions that can be used by other classes. The counter elements in different label function will return a hash table containing all label types and corresponding quantity. Find dominant label methods will find the label or class with largest quantity from the previous hash table. Get intervals methods will return the list of possible splits according to the current subset of data, and get subset. These methods will return the subset according to the refine of a certain value of a certain attribute. Now, the DT algorithm class contains the main algorithm function. It generates the decision tree recursively and finally return the root of the tree. In each recursion, it will generate a tree node. If it reaches a stop condition, that means there is less than 2 cans of label. Or this is the last attribute. Or all attributes in candidate set has the information gain of 0. That means the choice equals to -1. If not, we will continue generate the tree. The info gain class is designed to calculate the entropy and information gain according to a specific node. It calculates the total entropy in calculate total entropy methods. Calculate new entropy methods will calculate entropy according to the choice of each candidate attribute. Finally, the choice of attribute methods will return the attribute with largest information gain. If no such attribute exists, return -1. And the pruning class will use REP methods recursively prune the generated tree. If cutting a certain node won't increase total error rate, then cut it. Finally, the testDT class contains the entrance of our program. Also, the cross-validation will be executed in this class. We shuffle the raw data before we do training and cross-validation. We generate the decision tree like this. We do 100 times of cross-validation, and our final average accuracy is around 88%. That's all. Thank you.